Greetings. Today's lesson is very much important for mathematical physics and engineering mathematics. This is very basic of these two part, and this is very important for these two part. We'll start with vector. In this lesson we'll learn just some basic rule definition and vector product. Basically we'll complete vector algebra today, and from the next lecture we'll start the vector calculus. Let's start on the ch- the first thing is the definition and difference between what is scalar and what is vector. A vector is basically a physical quantity having magnitude and direction both. Where scalar is a physical quantity what only have the magnitude but no direction. The vector always obeys the vector algebra, but scalar obeys the normal algebra. Some example of vectors are velocity, force, etc. And some example of scalar are mass, energy, volume, because these terms velocity, force have direction and magnitude both, but these terms must have only the magnitude no direction, energy have only magnitude no direction, volume have only magnitude no direction. So these are the scalar. Now learn about unit vector. A vector with unit magnitude is defined as unit vector, like vector A is equal to xi cap plus yj cap plus zk cap. This unit vector is written as a cap is equal to a by mod of a. This is unit vector, and that implies that a cap is equal to xi cap plus yj cap plus zk cap by root over x square plus y square plus z square, basically mod of a. Now let's understand some properties of vector operation, like a plus b is equal to b plus a. This is called commutative property of a vector addition. And then if it is a plus b plus c, it can be written as a plus b plus c. This is called associative property. A plus 0 is equal to a. If any vector is added with a 0 vector, this is called a 0 vector. This is additive identity. For the mention, this 0 vector is not exactly 0. It have magnitude of 0, but it have the direction. Um, Next, we will learn about multiplicative identity. 1 into a vector is equal to a. If it is not 1 and any another number 6, 7, 8, k, then it will be get that number into a. This is the scalar multiplication of a vector. 5, a plus minus a is equal to 0. This is additive inverse property, we can say. How? If it is a and the opposite direction that same, it is minus a is equal to 0. And last one is distributive property. N into a plus b can be written as n a plus n b. This a b, these are vector. Addition of vector. How can we addition a vector? If of two given vector a and b are in that direction, then the given vector, another resultant vector c will in that direction, not that direction. C will basically opposite of this flow. And another way we can find it, that if we complete the parallelogram, then the diagonal is their resultant, and the direction of is direction of that resultant is the opposite what this flow have. That in the, it was this flow, that flow was could be this, but the resultant vector is not like this, that is the resultant vector. Okay. A plus b is equal to c, direction of each vector shown in that image. Subtraction of vector, like two given vector a and b can be written as a minus b, can be written as a plus minus b. Minus b would be in that direction. If it was in that direction, that will be the minus b. Okay. The next one is vector product. The two type of vector product is very much important, and we'll learn it here. The first thing is dot product or scalar product. What can be defined as vector a dot vector v is equal to mod of a into mod of b cos theta. This theta is angle between these two vectors. And another type of vector is cross product or the vector product. It can be defined as a cross b is equal to a b sine theta, mod of a mod of b sine theta. Uh, Let us explain little more. The dot product of A and B is denoted by A dot B. A dot B is equal to mod of A mod of B cos theta. This theta is angle between two vectors. Now look at that. B dot A is equal to mod of A mod of B cos minus theta. Now cos theta, why that is minus theta? Because this time it is not A dot B, that is B dot A, so it was in their opposite, so the angle is minus theta. But the cos minus theta is also cos theta, so we can write A dot B is equal to B dot A. This property is commutative property. Now we have that theta is cos theta, we define this in that manner. Okay, now just consider an orthogonal or perpendicular to vector. If this is, then the angle between these two vector will be pi by 2. Now cos pi by 2 equal to 0. So if we have two orthogonal vector, then their value cos pi by 2 is equal to 0. And if a vector of same line or parallel vector or collinear vector, then angle between them is 0. So a dot b could be written as mod of a mod of b cos theta. The value of theta is 0, cos 0, that can be written as mod of a into mod of b. And now let's take I, j, k, cap, I cap, k, j cap, k cap are the unit vector along mutually perpendicular axes. Then can be written at I dot j is equal to j dot k is equal to k dot I is equal to 0. Why? Because the angle between these vectors are pi by 2. So cos pi by 2 is equal to 0. So their angle is 0. So A and B are the orthogonal vector if their dot product is 0. Let's know some go to the some another property. M and n are two scalar and a and b are two vector, then m dot vector a into n dot vector b can be written as n dot, vector a dot m vector b. This is called associative law. This property is associative property. And another thing, now consider three vector, vector a, vector b, vector c. If vector a dot vector of b plus c, then you can be written as a vector a dot vector b plus vector a dot vector c. This is the distributive law. Let's consider two vector. A is equal to vector a is equal to x I cap plus a y j cap plus e z k cap, and another vector b is equal to b x I cap plus b y j cap plus b z k cap. If you have to find a dot b, then a dot b is equal to ax bx ay by plus az bz. Why? Because this term I j I dot j j dot k dot I is equal to 0, and I dot I is equal to 1, j dot j is equal to 1, k dot k is equal to 1. So we just have these terms, and these terms will be cancelled out. So a dot b is equal to it is. Now if a cos theta, the what can be max to max value of cos theta? That's maximally 1, otherwise that is less than 1. So a dot b will be always less than or equal to mod of a dot b will be always less than or equal to mod of a into mod of b. This property is actually Schwarz inequality. Now go to the cross product or vector product. Come a little more complicated than before the dot product. It is the cross product. If a and b two vector and see their cross product or see their cross product, okay, then c can be defined as a cross b is equal to a b sine theta n cap. This n cap is unit vector along this resultant. It can be determined by right hand screw rules. Now let's come to the some characteristics of the vector. A cross B cannot be written as B cross A. Why? Because A cross B is equal to, can written as A mod of B sine theta. But when we are writing up B cross A, then that is sine minus theta. Now sine theta and sine minus theta is not same. Sine minus theta is basically minus of sine theta. So A cross B is equal to minus of B cross A, not equal to. In vector this direction is very important, so these cannot be same, so we cannot write this, so it's failing commutative law. Look at we have done. Now vector or cross product of two parallel or collinear vector is always zero. Why? Because for a parallel or collinear vector this angle theta is zero. If this angle is 0, then sine 0, value of sine 0 is 0. So the the vector product or cross product of two collinear vector is always 0. In the previous part we have learned that if we have to find any orthogonal vector, we just have to check that whether their dot product is 0 or not. And if we have to find if any vector is collinear or parallel vector, then we just have to find their cross product and find whether it is 0 or not. If it is 0, then it is a parallel vector or collinear vector, but if it is not, then it is not a parallel or collinear vector. Now cross product of perpendicular vector A cross B, if it is perpendicular, then the sine pi by 2 is equal to 1, because for perpendicular pi by 2 sine pi by 2 is equal to 1. Then A cross B, A dot sorry, then mod of A into mod of B and n cap. N cap is the direction of that shit. Cross product of an equal vector. Let a vector A cross A is equal to mod of A into mod of A sine 0. Basically two equal vector have the same direction. Same direction means the angle between them is 0. Angle between them is 0 means we already have that collinear vector or parallel vector, their cross product will be 0. So for two equal vector, cross product will be always 0. If m is a scalar and a and b are a vector, then small m a cross b can be written as m a mod of b sine theta. Now we can written as mod of a into m cross b, that we already have learned that can be written in that property, because it is scalar function, scalar and sine theta. It can be written as a cross m b vector. So it's follow the associative law. If a b and c three vector, then a cross b plus c can be written as a cross b plus a cross c. One final thing we have to understand, that if a is equal to ax I cap plus a yj cap and a zk cap, and b is equal to bxi cap byj cap bzk cap, then if we have to find their cross product, we just have to and put it in this matrix structure I, J, K, X, A, Y, A, Z, B, X, B, Y, B, Z, and we will find it. Okay, what we have learned today? We have learned basically the very basic some definition, what is scalar, what is vector, what is unit vector, some basic definition, and this, and then we learn the dot product, the cross product. We'll attach some study materials with you. If you want it to go through it, you can go through it. For your convenience we are doing this. Thank you.